In this lecture, we will introduce the binary search algorithm.
Before we show how to do a binary search, let's play a game just to show how effective binary search is. Let's say you're asked to guess a number between 1 and 100. If the guess is higher than the answer, then your next guess should be lower than that. And likewise, if your guess is lower than the answer, your next guess should be higher. So you're just going to keep guessing until the answer is found. It's kind of like the high-low game from Price is Right, if you remember that. The only difference is you don't really know the upper bound on the price. But you say a guess and you'll be told if it's too high or too low, and you just keep going until you get the correct answer. So if we need to guess a number between 1 and 100, what should be your first guess? Think about it for a second. If you're trying to figure out if your guess is too high or too low, the best guess would be 50. And this is because if it's too high, then that means you could pick a lower number. And if it's too low, then you pick a higher number, obviously. But this eliminates half of the guesses. Because like if the answer is really like 25 and you guess 50, then you don't have to worry about 51 through 100. Likewise, if it's too low, you don't have to worry about numbers 1 through 49. So you just cut off the number of guesses by half. All right, well, if your first guess is 50 and it's incorrect, what should be your second guess? Well, it depends on whether your next guess needs to be higher or lower. If your next guess needs to be higher, it should be 75, and if it's lower, it should be 25. So either 25 or 75, depending on whether 50 was too high or too low. So notice in this case, we cut the remaining guesses in half again. So the idea with this guessing game is that we should just keep cutting the number of guesses by half until we get the correct answer. Let's do an example of this game. So let's say the correct number that we want is 33. And we're going to guess until we get the 33. So our first guess is going to be 50, which is clearly too high. So now we need to pick a number between 1 and 49. So let's just pick the second guess, which would be 25. So we cut the number of guesses in half. We're going to be told that that's too low. So now we have to pick a number that's between 26 and 49. So we need to cut the number of possible guesses again. So in this case, we're going to guess 37 as our third guess. We'll be told that this is too high, so we need to pick a lower number. So now we need to pick something between 26 and 36. So in this case, we're going to pick 31 as our fourth guess. We're going to be told that that is too low. So we're going to pick, 31, that's too low. So we need to pick something between 32 and 36. So we'll pick 34 as our fifth guess. We're going to be told that's too high. So now we need to pick something between 33 and 32. So we're going to end up picking 32 the way that you would do integer math. We're going to be told that's too low. So we need something between 33 and 33. So our seventh guess is going to be 33. And we're going to be told that that is the correct answer. The game we just played is an example run of using binary search. And notice that when we did that, we only needed 7 guesses to get the correct answer. Now, what if we'd use the sequential search or the linear search? Well, we would need 33 guesses because we would start at 1, 2, 3, and go all the way up to 33. So we see here that we have this comparison between doing 7 guesses and 33 guesses. So we already see that there is a pretty nice improvement with using binary search over sequential search. Let's take a look at the actual code for the binary search algorithm. We'll go over more details about it in just a little bit, but I just want to show you the code and what's going on here. So we're going to pass the array, a, the size, and then the key, which is the element that we want to find. So we have a couple of variables at the beginning to help us. We have a low and a high variable, which are integer variables. We're going to use these as kind of our searching range. And then we have a while loop that keeps going as long as low is less than or equal to high. Because since we're going to keep moving low closer towards the middle and high is going to be closer towards the middle. So in other words, we're going to end up increasing low and decreasing high. It could happen where they actually end up crossing each other. And if that ever happens, then we know that the element is not in the array or key is not in the array. So we would return -1. Now what goes inside the body of the while loop? Well, we're going to have a mid variable, which is going to give us the midpoint between low and high. And we're just simply going to do some comparisons. about whether this midpoint is the value that we're looking for, or if it's too low or if it's too high. So we see here that if our midpoint, or the value of that midpoint, is too low, then we know that our next guess should not include anything lower than that. So we're going to adjust our low variable. And if it's too high, if it's too large, then we know we don't need to guess anything larger than that. So we need to change our high variable. And if it's not too low, it's not too high. So if it's exactly correct, then we're going to return this mid value, which is the index of exactly the value that we're looking for. So here's some more details with what's going on with the algorithm. So we have our low variable initially be the first element of the array. So it's going to be 0. And we're going to have our high variable be the last element of the array. So we're using both low and high as the range of elements of where key could be in the array. So initially it could be anywhere in the array. So we're going to just check the middle element of this. So we're going to check the midpoint, kind of like what we did with our guess. So here, this is where we compute mid to be low plus high, take that quantity and divide it by 2. And then what we do is we check the element at mid to see if it's the value that we're looking for. So if our key is at a mid, then we're done. We found the element. So we can return the index and just say we're done. We don't have to do anything else. Now, what if the key is not at a mid? Well, we still need to compare the two values. And we have two possible cases if they're not equal to each other. Either the key is greater than a mid, or the key is going to be less than a mid. So let's consider the case where key is greater than a mid. And what that means is we know that all the elements from a low to a mid cannot have the key, because our guess in this case is it's too low. We need to pick something higher than a mid. So what we do is we'll set our low to mid plus 1. We could set to mid, but it doesn't do us any good because we already know that a mid is too low. So we need to change our search range to be from mid plus 1 to high. So now we reduce our search range to where key should be in. So because we know key cannot be between low and mid, so let's just eliminate all those possibilities. Now, what if the key is less than a mid? Then that means we know we've guessed too high. We know that all the elements from a mid to a high cannot have the key, so we need to change our search range again, so we can set high to mid minus 1. So we know that the key is somewhere between low and mid minus 1. So either way, we're cutting down the number of elements to search in half. And this is crucial when we analyze the running time of the algorithm, that we're cutting down the number of options in half with each guess. So once we've changed the value of either low or high, we can now repeat this whole thing where we find a new value of mid based on the new values of low and high. So we just compute the mid, we'll compare it. If they match, we're good. If not, then we're going to cut the elements in half. Now, if we keep cutting the search area in half, eventually the search area is going to be too small to do any more cuts. So let's say we get down to one element left to search, and this would happen whenever low and high are equal to each other. If it's there, we found it. Great. Now, if it's not there, we're going to continue our algorithm. And just depending on how it's set up, we're either going to increase low or we're going to decrease high. No matter which approach we use, we're going to end up having low being greater than high. And that means the condition of our while loop is false, and that is when we know that the key cannot be in the array. So then that's when we can return -1 to conclude that the key that we're searching for just does not exist in the array.